in the eyes of OSHA, how they enforce what the role is of the NFPA 70E. That is the National Fire Protection Association, Chapter 70, the electrical, on how to work safely with electrical devices. The main components of that standard and the changing. Unfortunately, we're having some issues in that. Oops, just trying to get the button here. Have a little bit of a technical difficulty, but we're moving forward. Thank you. Arc flash hazard. I wanted to start with this because, as I said, it's relatively new for us old timers in the industry. And we want to talk about what the arc flash hazard is. Well, it's that electrical spark caused by shorting phase to phase on a 3-wire or a 3-phase system, or phase to ground, causing the electrical spark lightning that we're all familiar with outside is an electrical arc. It's very dangerous. It is electrically conductive. That blue spark is moving electrons. It's very hot, as you can see, anywhere from 5,000 degrees Fahrenheit for a small category 1 up to 3,500 degrees Fahrenheit for a category 4 or higher. You don't even have to be close to it to get burned. The heat can be extremely intense, and just being around it can cause a problem. If you're in the arc and it goes by you, hopefully it doesn't last for very long, because we don't have many materials that can stand a sustained temperature of over 10,000 degrees. Also, when this arc goes off, we all remember lightning, there's a bit of thunder that comes afterwards. Same thing here. The arc flash will start, and there will be a large pressure wave generated from that arc. It's enough to cause hearing damage because it's extremely loud at the point of origin. We also have things that start to fly out of the panel at us. We have melted metal. We have pieces of copper, be it the bus bar or wires or other devices that were in there that are in the arc, that is the path of heating, current flow. Also, we get shrapnel accelerated out of that panel. We have a large amount of air pressure because of the expanding heat that helps motivate or push these things out of there. It's not a common everyday occurrence, but when it goes bad, it goes bad. The effects of arc flash, we have about 2,000 reported electrical burns. Some of the OSHA data is okay. OSHA's changed their reporting systems, and of course the 300 systems going back for major employers is changing. As we go forward, we'll get better data, but from what we can tell right now, about 2,000 people a year are getting burned. And the burns can be from intense heat, or they can actually be an electrical burn. Remember, I said that arc flash is electrically energized. Also, people are getting hurt from that pressure blast. That pressure blast on a category 2 or higher is enough to knock a 200-pound man off his feet or off a ladder. So you need to be careful as you execute electrical safety. Toxic gases. Copper, when it's vaporized, is not good for our lungs and or other metals that come flying out of that panel. As the spray or the vapor leaves the point of the high temperature, eventually it'll condense and it'll deposit. It'll look like somebody sprayed metal droplets or texturized the wall 10 to 15 feet behind you. And obviously that copper is still very warm and it can cause burns. And if you've ever dropped a piece of solder on yourself when you're working, it stings for a bit and is gone. The copper's got more specific heat in it and causes lots of problems. The hearing damage can be quite significant. We want to wear hearing protection, and I'll get into the PPE requirements later. And of course, eye damage, because this is a very bright flash of light. And of course, you've got flying debris and other things coming at you. What causes arc flash? Well, there's one good kind of arc flash we call arc welding. But remember, we use a step-down transformer to lower the voltage, hence the power. And we use that to join metal pieces together. But we still need proper protection for that, right? The light is so intense, we have to be careful. You need welding shields. Traditionally, people are using leather gloves to protect themselves from sparks. And obviously, the metal is glowing red after the arc is stopped. So you've got a lot of heating going on there. But accidents happen. Unfortunately, we sometimes don't look at what we're doing, and we short out phase to phase, or we're in there tightening up a lug and the screwdriver goes across, hits phase to ground. That can cause that arc flash. Or maintenance comes from devices that are getting worn, motor starters, the loose contact. And sometimes electricians that have worked at industries not using three-phase power are definitely at a disadvantage, and they don't quite understand what that third wire is for. We also have people that don't follow the electrical lockout tagout procedures, and you may have panels that are fed by different sources, and all of a sudden you go and touch a wire that you thought was safe or grounded or dead, and unfortunately you can cause issues there. It's easy to be distracted when you're doing electrical work. You're in there, you're very focused on what you're doing. You're using a screwdriver, an Allen wrench. You're making sure not to accidentally ground, but somebody calls out your name, you're a loud noise. And it's just human nature to react to that, to turn, and you might end up shorting out phase to phase. I guess I'm in the category of these last two. Overconfident, I've done this a million times, I know what I'm doing. And you sometimes may forget a safety step. Or I've done this so many times, this stuff can't hurt me, it's just 480 volts. Well, that's really just not true. So be careful when you're working with this. What does electrical safety compliance look like? Well, they want you to understand, that is, they being OSHA, the hazards that are in your house. So they want you to start with electrical hazard analysis, and that's in terms of voltage and arc flash. That arc flash hazard analysis turns into a study, and you need to calibrate, quantify exactly how much arc flash potential is at your location. It's site specific, it's equipment dependent, and you need to go through that. Also, when you develop your short circuit currents, you need to look at the panels to make sure that it's got the withstand capability of the short circuit current you're providing it. After you get through your hazard analysis, you then take a look, are there ways I can effectively reduce this? OSHA, of course, wants reduction as their first choice. They want to reduce the level of the hazards. And if you can't, then we want to come up with appropriate and feasible administrative controls. That is, how do you work around this? At what level are my people going to work at? What type of gear do they need? And are they trained to use that? The next step down would be identifying your hazards. OSHA wants these things, that is the panels, labeled in terms of voltage and arc flash hazard, because nobody should use their mind as that safety device. This is not a memory test. You want to be able to walk up to a panel, know that it has been inspected and it's been quantified. And gentlemen, this is exactly what the hazards are inside this panel. Here's what you need to protect yourself. And if you do that, you should be nice and safe as you go forward following your procedures for your facility. Of course, training is involved for both qualified and non-qualified electrical employees. Qualified people would be those that you, the employer, determine to work on your electrical system on a day-to-day basis. And many of our employees are not trained and qualified to work inside of electrical panels, but they still will have some electrical duties from time to time. But Tom, what are you talking about? Well, many facilities need an extension cord from time to time. You need to plug that in, so you're using an electrical device. They need to be a little aware, making sure that the cord is okay, it's got good 3-prong plugs, and they're not standing in a water puddle when they plug in that extension cord. So there is some minimum level of electrical training required for our non-qualified employees. OSHA's position on electrical safety and compliance. OSHA's charged with safety in the workplace. And since they've been administering this since 72, the last 10 years, unfortunately, electrical injuries and death have been climbing. Unfortunately now for General Industries, we're in second place. A bad thing to be in second place on. Unfortunately, due to the severity of electrical hazards, about 1 in 25 electricians or electrical qualified workers that get injured end up dying from their injuries. And that's why OSHA is, quote, raising the bar. They're trying to make it safer. They're trying to improve our approach to electrical safety to be better. And OSHA does that through the NFPA, the National Fire Protection Association, to improve electrical safe work practices. What is the role of the NFPA? Well, I'll kind of explain it to you as we go here. OSHA has their regulations published for general industries, construction, but referring back to general industries here, it's section 300. It came out and started with the use of the National Electric Code to try and understand and explain how to work safely with electricity. Unfortunately, that wasn't enough. It was very difficult for OSHA to work with, and that's why this construction guide, the National Electric Code, was a starting place. OSHA actually used some of the charts in here to establish some of their early distances in working from electricity, which wasn't a bad thing since they didn't have much else to choose from. But the issue we have is that this code's not universally enforced. 3 states don't even have a city or a state electric code. And the 47 states that do have it are at 5 different edition levels. So it's not uniform. It's very tough for non-trained, non-electrical people to understand. But the good news is, if you follow the National Electric Code for your installation, you'll end up starting off from a safe point. So it's an excellent system, excellent regulation when used properly. NFPA 70E, this was written at the request of OSHA to help understand how to work safely in the workplace with electrical devices. It's a consensus standard. This is not a regulation like OSHA. This is not an act of Congress. This is not a law. This is a regulation. There's 24 voting members that are on this council, and it started back in 79. OSHA started in 72, so it took a little while to get this thing rolling. This is in sync with the National Electric Code. They're both revised every 3 years. As the code changes, the NFPA tries to stay up with that, and of course, any feedback that they have from OSHA. It started rather simply as 1 part, actually grew over time to 4 parts or 4 chapters, and was reduced down to 3. They pulled out electrical maintenance because, as they found out, there was a lot more to electrical maintenance than they had covered here. But that's its own book and is part of the evolution of safety in the workplace. OSHA, under their regulations for general industries, 333A, they want you to be safe. Electrical safe work practices shall be employed to prevent electric shock or other injuries resulting from direct or indirect electrical contacts. They want you to de-energize. If that panel has been put in an electrical safe work condition, there is no hazard. OSHA draws a line at 50 volts, 50 volts and under. Yes, there's the potential of short circuits and heating and burning, but the 50 volts is not enough to be a shock hazard. And when you do the arc flash, 50 volts is not enough to cause an arc flash that puts you up into category 1. Even the simple act of going through a panel and de-energizing it and proving that it's de-energized can be a hazard, because until you've proved to yourself there's no voltage, you have to assume that there is a voltage in there, and you've got to be on your toes when you work with electricity. Now, there's OSHA citations that come through from accident investigations or other investigations that OSHA does from time to time. They will cite different clauses. Many times they'll fall back to the general duty clause, because you as the employer need to furnish a safe workplace from hazards. Now, also they will cite against section 300s. They'll typically use 2 or 3 sections in there, one for having PPE and the use of PPE when you're in an electric panel. They also have the training. They also want to see an electrical safe work practices manual. So OSHA will cite in certain circumstances under 300, and when it doesn't quite fit there, they'll always fall back to this general duty clause. The main components of 70E. Well, they want you to analyze those hazards. We're going to start at your incoming power feed to your transformers, all the way down to your equipment. They want you to develop one-line drawings, because it's a great vehicle for conveying what the different levels of arc flash are within your system and the different voltages. So it's a great graphical representation of what you've got. They want you to determine, how does this place run? Are we fed from 2 different power feeds? Do we have a standby generator? Do we have solar power, wind power? What are our sources of electrical energy? And they want you to get in and determine, how does this thing run, automatic transfer, manually transferred, and then from there, your bolded fault current. And that is a combined study looking at your incoming power feed, your equipment, and also in-house, the size of your motors, the type of the motors, and your neighbors also have some effect on you, in that if they have a large number of big motors, over 50 horsepower, there will be some added boost to the short circuit current in that area that is in addition to what the generators of the power company can put out. So the electrical systems are rather complex and need to be looked at properly to understand what that is. And from there, we develop what the arc current would be. Obviously, there is some resistance through the air, and we're learning more about arc flash all the time. We're finding out geometries of the bus bars, spacing of the bus bars has an influence on the level of fault current, arc fault current that is. So from there, we take a look at what the devices are in terms of fuses and breakers for interrupting a short circuit. How long does it take for them to open and clear the short? And that's used in addition to how far away you work from that device. That is your working distances. Are you an arm's length away, 18 inches? Is this a high voltage gear where you're working typically 2 feet, 3 feet away or more? And based on that distance, you calculate the energy that's impressed on you. That's the incident energy. That will develop the arc hazard category. And then we'll, from there, backwards calculate what the arc flash boundary is. Sometime that arc flash boundary can be quite significant on your incoming category 3, category 4 power panels. 10 feet, 12 feet, even up to 20 feet. That arc flash could extend out to the panel and provide a level of energy that is a hazard. OSHA defines that at 1.2 calories per square centimeter. Then after you've got all your analysis done, as I said, they don't want electrical safety to be a memory game. They want you to label your components so that the voltage is known and the arc flash is known and what type of arc flash category you're looking at. Your Electrical Safe Work Practices program is a site-specific, employer driven set of self-imposed regulations on how to work safely at your own facility. There are no two facilities, no two manufacturing sites that are absolutely identical. We all do different things. We have different types of electrical connections, different transformers, a bunch of different size motors, different size wire and lengths of wire. So you need to analyze your facility and decide what works for you. You may be a relatively small manufacturer, or you say, I'm going to just do a very bare minimum of electrical work. You may even decide, I'm so small, I'm just calling an electrical contractor if I have a problem. That's okay. It's your facility. You get to make the decision. Now, there are many large manufacturers where I can't afford to wait for an electrician to show up. I have to have my own people fully trained, fully qualified to work on anything that I have in my facility. So that's why the different procedures are required, and that's also why you get to set the standard for who is electrically qualified in your own facility. Once you've made that decision, you can start training your both qualified and non-qualified personnel. Obviously, understanding the hazards of voltage and arc flash is extremely important. And then you need to train them on what they're going to be doing or what you expect them to do, electrically speaking, in your facility. We also then need to enforce putting things in a zero energy state or a safe state, and that's sometimes called being in an electrical lockout tagout condition. It's a little different than authorized lockout tagout because we're going to use their skills of electrical worker to prove and verify there's no voltage over 50 volts that can hurt anyone. There's a few extra steps required, and it is very important. This is something new they're pulling forward into the regulation of 70E. Used to be in the background, back in the annex, but it's important, and they pulled that forward. Also, how to work on energized components needs to be part of your system. Maybe you're going to have a decision level of Category 2, Category 3, Category 1. What level of PPE do you as an employer want to supply? What do you feel safe for your electricians working on? And you put a self-imposed internal limit on and say, my people have the equipment and the training to work up to Category 2. Anything beyond that, I'll call in outside people. Some of the electrical gear can be a little expensive, and if you're not using it all the time, it may not be the best investment. So that's why you have to provide the electrical gear, the PPE, the arc flash gloves, the voltage gloves, the whatever level of suit and protection is required to work in the different categories. Also, this gear needs to be maintained properly, stored properly. Certain things like gloves and other electrical gear need to be sent out for independent testing and verification. So there are methods and procedures you need to follow to make sure you've got a good electrical system. Personal protective equipment. We used to have an older category called Category 0. And from this, it was sort of implied, oh, Category 0, it's no big deal. I can be safe. I can wear a cotton shirt, long sleeves, cotton pants, safety glasses, and I'm fine. But what happened is when you cross that arc flash barrier, you reach a point now where the arc flash energy is strong enough to cause that burn. So even the old Category 0 panels, if you got close enough to electrical conductors, you got a problem. That is, you had to remember to go up in category protection, and that would be Category 1. There we go, Category 1. Sorry, it took a second to get it up. That's now basically from an arc flash intensity of 1.2 calories up to 4 calories. It's now the bottom level of arc flash. And as we indicated, it implies that there is a sense of danger or hazard here, and you need to be protected. Now you can see there's more and more items that are required for your body or whatever is inside of this arc flash barrier to be protected. As we go up to category 2, the level of protection goes up. Category 2 rises up to 8 calories per square centimeter. The clothing gets heavier, and now we also need protection for our neck area. Why? Remember we talked about the sound wave and the pressure wave that comes out from an arc flash? It's now to the point where it could collapse your windpipe and cause real trouble in breathing. So we need to be protective of those hazards that we face as electrical workers. As you go to category 3, traditionally these might be a jumpsuit or a pullover going over the top of electrical gear to gain this higher level of 25 calories per square centimeter protection. Category 4 basically looks like you're going to the moon. You just put on a set of bibs, coat, and it basically looks like a welder's hood, but it's an electrical category 4 hood. It does have a welding type shield in it that's arc rated that would reduce the intensity of the arc flash so that you don't get eye damage. But it's a completely enclosed hood with an electrical hard hat inside of the hood so that you can withstand the pressures and the impact of that arc blast. Training. Another big feature of the 70E. You need to train your people so that they understand the hazards of electricity and understand your facility and what is required of them to work safely in your facility. Now, since this is your house, you get to determine what people are qualified for. It's very good news because it would be difficult for manufacturers to send all electrical workers to outside training schools such as an Allen Bradley variable speed drive school or a Siemens programmable controller or Siemens switchgear. What we can do is use the second note. Once you have an in-house expert that has come back with training and has been approved to work on those devices, he can have the non-trained person on that device work with him, such as an electrical apprentice, understand the system, and then once this training person gets to a level where he can demonstrate proficiency and being safe with working with this device, you can deem him to be qualified to work on that. So it's a great way of having an in-house training program to guarantee that eventually all your people will be qualified to work on all your different devices inside. Oops, I'm sorry, I skipped your electrical non-qualified training issues. And that is, we talked about if they have to get into some electrical work, like plugging in the extension cords, they need to inspect the extension cord and make sure that it doesn't have any major nicks. It's got all 3 prongs, especially the ground prong, and that they're going to plug it into a ground fault receptacle because a lot of cases you're working near doors and openings and you want to make sure that those people are protected. Also, it's human nature that you may have plugged another device into an outlet and all of a sudden the power goes off. It's like, oh, I know what happened. I plugged this new sweeper, this new local heater, and it tripped a breaker. So you walk over to the panel, and if the panel has all the openings protected, you can reach in and reset the breaker. We've all learned how to do that at home. But there are right ways and wrong ways of doing that, and that's why you need some training for your non-qualified employees to make sure that they are safe around electricity. Changes in the 70E for 2018. Well, they're raising the bar, as I said, because of the increased level of injuries and accidents in electrical. You are now responsible for a identification of your hazards, and they want you to do a deep dive on the risk assessment of both voltage and arc flash. They want you to not only understand the voltages and the levels of arc flash you're working on, but have your people worked at these levels. Traditionally, there's 2 levels of electricians those that are qualified in 600 volt systems and under, and those that are working on high voltage. So there are different skills, there's different techniques, there's different equipment. And so you have to make that decision. Are you going to supply that equipment? Are you going to train your people to which level and which level of arc flash? So that's all up to you. We also, as we expand, bring in new equipment or modify our system significantly, we need to state that that construction was done to the local codes. Why? Because that's the right starting point. If you pick the right wire size, conduit, power supply, size of breakers and the fuses properly, provided for a good grounding system, that's the place where you start with a good electrical system. They also want you to do a written job safety plan and then conduct a briefing to your employees. Now, if your employees have done this many times over, the briefing can be rather short because they understand the circumstances they're working under. If you're sending them into a non-known part of the facility they've never worked in before, they may need to identify the locations of the equipment, how the interlocks work, different power sources. So you need to explain enough that the electrician has the ability to execute his job without being exposed to additional hazards. Also, because we are rising in the rate of injuries and death, they've included you to have a incident accident investigation plan in your safe work practices. They want you to be able to identify the root causes of electrical injuries, and it would be shameful, really, to repeat the same level of injuries and accidents. If you can understand what caused it, step up and go fix it. Is it training? Is it equipment? Was it a device? And plug those holes, please. Also, when we work without the leather protectors on our voltage gloves, they have some new requirements for that because we're understanding how the long-term exposure to ozone working in panels can affect those rubber gloves. The risk assessment procedure also, as we said, talks about the human factors. How comfortable are people in working in this condition? Have they done this before? Have they demonstrated this before? You need to factor in their ability and their skills to get some sort of a probability of success or their risk assessment. And many people have only a few electricians. They're too scarce, and you train them to a certain level and you decide probably to outsource many above. If not, then you need to have the training and the equipment to handle all the different levels of risk they may face. When you take a look at your system, you need to understand what's causing the hazards. Your voltage, your motors are either 480, 220, 110, or higher voltage, 4160, 2300. So you're kind of locked into your voltage. But your arc flash is something that the picking of the right kind of breaker, there are many new electronic trip breakers with different sensing units that can help trip quicker and reduce the arc flash level. Also, there's some old fuses we used to call current limiting fuses that have excellent application in today's world, and they were primarily set up to protect electronic devices like transistors and SCRs, but now are available in larger ampacities where you can protect an entire branch circuit of 600 amps at 40 volts down to category 1 or less. So it's a great way of reducing the hazards that your people have. Also, moving towards 24 volts controls voltage from 110. 110 has some potential inherent injury with it because it's over 50 volts. When you move down to the 24 volt level, you're below the 50 volt threshold, and now you can work in control panels if they have the lower voltage with minimal protection. Clearly, you need to work with people to understand how to put things into an electrical safe work condition. This also was something that was included in the annex of 70E. It's now been pulled forward. because it's that important. We want to make sure that people know how to put panels in a safe condition. Also, we need to take a look at the arc flash. These two, we're learning more about the studies of arc flash, their hazards, their effect on the human body. These were also some charts and graphs that were located in the back of the book. But we're now moving towards calculating the arc flash current in each device and then picking the proper gear for protection based on your on-site, your specific calculation. Way back when, they used to have a bunch of different graphs and charts, and you could pick category 1 or pick this category. And depending on if you were very conservative, you tended to round up and put people in too much gear. It encumbered the way they worked and also made it very difficult for electricians to execute some of their duties. Now, if you were on the very, at the other side of the spectrum, you may have understated your risk. You may not have put people in enough protection, and if there was a hazard, you may have had a real problem in case things went forward. So they want you to calculate what you have and use the right level. Arc flash clothing, we've learned a lot more about that now. We started with the gear firemen wore, called FR, flame resistant, but the industry stepped up and we've gone to arc flash clothing. And so this too is being brought forward, and we're moving towards a better system for protecting our people. Guys, we'll take a look and see if there's any questions. And please feel free to contact us either through the website or here online, and we will try and answer any questions that pop up.
If you do have any questions at this time, please type them into the chat box. Otherwise, as Tom said, you can reach us at 419-882-9224. On the screen now, you will see a list of some of the open enrollment classes that we have coming up. Tom will be out at Northwest State Community College on February 28th from 8 a.m. to 12 p.m., doing a much larger deep dive into this topic. And we'll also be doing the same class on March 28th here at the Cardinal office in Holland. On the right-hand side of the screen, you can see where we have a multitude of other classes that are coming up. If you're interested in signing up for any of those, you can please visit our website at www.cardinalhs.net. And if there are no questions, I'm going to go ahead and end this afternoon. I hope everybody has a very safe and productive day, and thank you very much for attending. Thank you very much.